The recording will stop. Okay, go ahead.
All right. Thank you very much for the invite, Joaf, and hello, everybody. My name is Tom Steiner. I'm a developer relations engineer from Google. Yeah, today I'm here to talk about rebooting the network information API. I made a couple of slides, and hopefully we will have some time for questions. The slides are available. I will share them after the presentation. And yeah, with that, just a little bit of background on the available data with the current API. So if you just type navigator.connection into the console, this is what you get. So you can see downlink max, effective type, on change and on type change, RTT, round trip time, saved data, and type unknown. So I ran this from my desktop computer. A couple of things that confuse people. For example, I'm on a Wi-Fi connection, but the API says I'm on a 4G connection, which, yeah, is the effective type, but it's kind of confusing to users really. And yeah, this is one of the things. The fact that there is on mobile, the type exposed as cellular or Wi-Fi has been identified as a source that could allow you to track users. For example, if someone enters an office building, they will switch to Wi-Fi. If someone leaves the office building, they will switch to cellular. With enough other additional data points, this is a privacy issue. And yeah, this is just a little bit of background. Can I use the Network Information API? You can see Edge, Chrome, Opera, Android browser, Opera mobile, Chrome for Android, Firefox for Android, Samsung Internet, QQ browser, Baidu, KaiOS. So I looked at it in a little bit more detail. On everything Chromium, we have the sort of full information, with the difference being, as you saw before, I was here on a desktop computer and type was just reported as unknown. Of course, Chrome knows that I'm on a Wi-Fi connection, but this is only exposed, as far as I can tell, on mobile. Firefox has a partial implementation. So you can see here, navigator.connection is defined. Navigator.connection.effective type is not defined, which means something like a test to see if effective type includes 2G will fail. And this has caused actual breakage of sites. As I said, I will share the link so you can just follow through. There's a web compat issue about this. Yeah, and this is Firefox with the partial implementation that's causing this. And of course, it's not to pick on Firefox. It's just something that I found that broke in real life. Nevertheless, it's a very popular API, and I was surprised by these numbers myself. If you look at the page loads in Chrome status, you can see that it's roughly on 40% of all page loads. So that's massive. I dug into the data a little, and I saw it's used in a lot of widgets that are very popular. So you can see here, there's Facebook's Messenger chat. So a lot of shops have Messenger integration. It's used by YouTube's iframe embed, which is also obviously very popular. It's used by a lot of performance plugins. So there's something called instant.page, for example, that sort of prefetches pages and web content. Sorry, web content. And it's also obviously part of a lot of web analytics tools, like things that you can buy, sort of. So if you go and find a web analytics provider, but also big companies like Wix have gone on the record to say that for their users, they just record this data as well. So there's also some company internal analytics going on, where big companies that power a significant part of the web, as Wix does, yeah, use this data as well. Some of the problems with it, there's an overlap with some of the use cases with what is now the Safe Data API. This essentially started, sorry, not essentially, initially started as part of the NetInfo API. So there's, as you can see here, Safe Data false. So this is exposed here. There's also Safe Data header. This was removed from the initial network API and is now an own API, Safe Data, as you can see here. But yeah, there is a certain overlap with the use cases that are defined by NetInfo and that are defined by safe data. It has privacy issues. So you can see Mozilla had the partial implementation, but left out some of the critical bits. Mozilla considered it harmful, and they say it's better that sites use methods to dynamically adapt to the available bandwidth, as this is more accurate and likely to be applicable in the moment. WebKit, Apple are a little bit more frank. They say, as the spec openly admits, this would be a privacy disaster because of fingerprinting opportunities. So this being implementing this, there is not an official WebKit position that you can ask on the WebKit dev mailing list, but this was sent to the as responses to the bugs that asked for the feature to be implemented. So I found this very interesting, and yeah, this obviously also explains why they didn't want to implement it. Interestingly, the tag had a pretty smooth and short and sweet review. They just said, in terms of API design, this seems reasonable. We understand that there are a number of trade-offs in this design space, and there is some risk here. However, we feel that publishing something in this space is generally good because it meets a significant need in the platform, even if it's not initially perfect. And this is what I want to highlight here, even if it's not initially perfect. This was done in 2016. Now it's 2021. So I thought it's time for a reboot. And some of you may remember these good old reset buttons on computers, also the turbo button, but this is another story. So I went and thought, how can I reboot this API? How can I start fresh with all these problems and maybe come to a point where we can get cross-vendor agreement on implementing this in different browsers. The objective for this was I wanted to limit the data that is shared about the network while still enabling the same use cases that were identified. There was an issue 91 that triggered this, which stated update the repo on the spec to show this is no longer being actively incubated. And Yoav and Noam and I talked a long time ago and said, yeah, we should do something. And as always, things didn't happen, but should have happened, but never did. So this trigger issue was actually the reason why I started rebooting and actually starting looking at this again. And yeah, this is driven mostly by issue 85 then and issue 84. 85 says, should effective connection type be a fixed set of values? And issue 84 said, can we just do metered? And Yoav commented in the Mozilla position discussion saying, let's focus on those. And this is what I did. So here's a proposal. You can see the new network information interface. It's very simple. It's essentially just a Boolean metered, and it's an unrestricted double sustained speed. And you can see an event handler on change. So that's it. How does this look like in code? Let's look at two examples here. Downloading non-essential content. So we have a variable non-essential content loaded as false. We have a function download non-essential content. And if the non-essential content is already loaded, we just return. Our job is done here. And then we look at if the navigator connection is not metered, which means we have the freedom to use as much data as we want. Then we just fetch whatever non-essential content and set our variable to true. And in the beginning, of course, we need to call this once, download non-essential content, and we can then listen for changes. So if the metered status should change, which can, of course, always happen, someone switches networks or I don't know, decides to pay more money on a hotel Wi-Fi so that instead of 250 megabytes that you buy for $100, whatever, they have 1 gigabyte that they purchase for $200, whatever. So they could say, okay, I'm no longer on a metered network, whatever. I'll just do this. So then the function would be called. Something maybe a little bit more challenging is limiting bandwidth usage. And for this, I looked at an example from a program called a tool called WebTorrent that allows you to download completely legal movies and series from the internet using the BitTorrent protocol. And it's documented here. So I just highlighted here the documentation. So you instantiate a new client by calling new WebTorrent, and you can set the download limit to the initial sustained speed in bytes, and I say 50% of it. And you can see here, I get this initially from Navigator connection sustained speed, which is defined in bits. So I divide by 3 to get it in bytes, which is what the API here accepts. And then, because my initial speed will, of course, not be the same all the time, I set up a change listener and say, if the current speed in bytes, current sustained speed in bytes changes, I just set the new client by calling the client throttle download to the 50% of the available speed that I have in theory, so that I can have this running, but I don't consume all my bandwidth. And it dynamically adopts based on whatever my my network speed is. So this is not a made-up example. This is actually something that people use in practice. So WebTorrent is a very popular thing for watching completely legal content on the internet that you can on the fly download from your peers. Client-hint HTTP headers. So I defined client-hint headers that accompany these new properties. So you can see sec.ch for secure client hint, immediate connection, and sec.ch sustained speed. They just simply reflect what the two attributes do. Quick example, the server announces that it accepts network information client hints. So you can see here the accept ch header, sec.ch immediate connection, sec.ch sustained speed. And it also says that it will vary the response based on if something is immediate connection, because in this main example, I will say, if I call a list of products, I will, if the user is on immediate connection, not return all the whatever 500 products that I have, but only a subselection that is optimized for the lower connection speed. And then you can see here the client responds and says that it's on a immediate connection. So 1, it's a Boolean, so it reports as 1, meaning it's a immediate connection. And sec.ch sustained speed essentially reports that it's a 50 Mbit connection. You don't know if this connection is DSL, you don't know if this is Wi-Fi, cellular, 5G, 4G, it doesn't matter, because all we want is the absolute speed. And the speed would be divided in buckets, so you don't get the exact speed, but you would essentially take a sliding window where the operating system has observed the speeds in the last whatever, 30 seconds, what have you, and then it would be put in buckets. So essentially the idea is I looked at what is average internet speed globally. 50 Mbit is roughly where we are at right now. So this covers the entire world. So fully developed countries to in development countries to countries that don't even have internet all the time. So 50 Mbit seems like a reasonable thing to start with. And then I just say I grow this exponentially. So the next bucket would then be 100 Mbit. The next lower bucket would be 25 megabits. The reason for this, so exponentially growing, is a law that someone has put up that holds true, just like the law for the CPU speed, that each year we will double our connection speed. So this is why these buckets are defined like that. You can see all the resources here, so everything is available. The slides you can find at NetInfo reboot slides. I wrote a motivational document where I started this that goes into more details than the slides, NetInfo reboot motivation. And then I started working on an explainer and a spec. The spec is, so I forked the NetInfo repo, which means I can't really, as far as I understand GitHub, run my own GitHub pages on this fork. So I used whatever raw git thing that I could find, and it seems to be stuck at an older commit right now. The current spec, let me just leave full screen. The current spec is on my local host. Yeah, so you can see it's in a okay shape. This is my very first spec that I start from scratch. So there's probably things that are wrong that experts will figure out. For example, initially I had named my attribute is needed. Dominic corrected me on that, so now it's just needed. So there will be some mistakes in this. You can see there is an explainer that is a little bit less formal. So you can see here where this data comes from. On Windows, you can toggle this little thing here and say my connection is needed. On Android, you can do the same. You can say, where is it here? No, it's here. Network usage, treat as needed. So on Android, you can say my connection is needed. This is how it looks like when you look at the task manager in Windows. You can see here the connection speed. I did a speed test, 50 Mbps by accident, also my actual DSL speed at home. So you can see here, this is what was observed. This is what it looks like in macOS Activity Monitor. So it's a little small somewhere down here. There's, of course, Linux tools that do the same. So you can run nettop and you get information about your network. So the idea is the network information is already available on the operating system level. The user agent would then take this information and do the bucketing. Something I found would make maybe Mozilla or maybe Brave, I don't know, happy would be if I say sustained speed is something that I consider as a user agent privacy sensitive or too privacy sensitive, I can just report infinity, which is why my sustained speed attribute here is defined as something that is infinity, can be infinity, so it's a double. Examples here, and this is the client end example. And you can see a lot of discussion is still happening in the motivational document. So you can see this is the NetInfo reboot motivation document. So I would very much welcome all of you to look at the repo, look at the spec, look at my little explainer, look at this document. And just ask your questions, make this happen. And my plan for this is bring everything in a shape that is free of errors, that are mechanical but fixable, and then reach out to other vendors, reach out to the tag, get an early stage review, and then hopefully start implementing if you all think it's worth the effort. And with that, thank you very much for listening. And I guess we have, 6 minutes time for questions.